Hello and welcome to Advent of Code in F# day 20 already. So we're counting down the days toward the end. Let me share my screen. There we go. I already read today's exercise, and it's about puzzles. We have to lay a puzzle, or no, not for part 1, but I'm guessing that for part 2 we need to lay a big puzzle. And the puzzle pieces, or actually it's we need to reconstruct an image, and we get tiles like parts of the image, and they can be rotated and flipped. Flip does not make much sense with the physical puzzles, but yeah, we have tiles which are like little puzzle pieces, and we have to find the corner pieces for part 1. So we have to lay the puzzle, and every tile can line up to its adjacent tiles if we rotate it correctly. So the borders line up nicely. And we need to find for part 1 the 4 corner tiles. The second I heard rotation and flipping, I was thinking, oh, this is going to be easy if we use like some kind of matrix stuff. If you look at the Advent of Code or people doing Advent of Code in Python or Go, you see a whole lot of slicing going on. So interesting array indexing basically. And then I remembered, wait a second, F# has this as well, but I never use it, so I did a bit of research beforehand. And I couldn't find like a good example online, but I remembered where I found it, and it was in this book, the book of F#, and it was something called Array2D, which is basically a module that lets us work with matrix or with two-dimensional lists or arrays. Yeah, but let's not go too much into the theory. Let's just try it out. So I grabbed my example. I grabbed my input. I have them right here. And let's start thinking about this problem. So as I already said, I would like to represent each tile as a 2D matrix or an Array2D in F#, because that will make it easier to do stuff like rotation and flipping the tiles. But first we need to parse the tiles so we can actually work with them. So let's start with that. Or let's maybe first start with the type. What will a tile look like? Every tile has an ID, which is a number. It's not that big of a number. And then we have the contents. Yeah, let's call it contents. So that is a two-dimensional array. This is the syntax of characters in our case. Should we parse them? It does not matter for part 1, so let's just keep them. This is weird syntax we haven't seen yet, so this is why I want to solve today with these kinds of data structures. It's completely new to me, or not completely new, but I have not used it this year, so let's try it out. This is what our tiles will look like. Let's try parsing the example into something like this. So the input is a big string with all the info, and we need to split on the tiles, which is, what was it, an empty line? Yeah, so let's split on an empty line. Empty line, what is it? Carriage return new line, carriage return new line? I think so. It needs, I dislike the string split API in C# or in .NET. I hate like providing this string split options all the time. If there's a way to not have to provide it all the time, if there's like something else I can use, please let me know. Okay, this parses or splits on every tile. Let's run that on the example so we can follow along in the REPL. Yeah, that looks correct. And now for every tile, let's parse the tile information, and let's just keep working on lists. So now we need to parse a single tile. Which is the ID and the grid. The ID, are we gonna regex? Yeah, we're gonna regex. I have a newfound love for regexes since, what was it, day 18 or 19? I use a lot of regexes this year. How can we extract the tile ID from this string? It's tile, and then we have the ID, and semicolon. Okay. Text is actually multiple lines, so we need to split it into its lines. It's a string. Let's help the compiler. Again, splitting on new line. I'm not even going to type it because I still am not used to QWERTY. I switch between QWERTY and AZERTY a lot for work, and it's not a good idea. So text split on a new line. Yep, so these are the lines. First line is the tile ID line, so let's extract the ID of the first line by matching the regex. And it's in the first group, our ID. Yes, it is. So that's 1. The value, let's parse that to an int, so that should be the tile ID. What's not to like? This expression is not a... What? Is it this? Oh, sorry. F# is picky about calling methods like match, and then no, it's not a problem. Interesting. That's a regex. You can call match using an input string, and that returns something. Nothing. What's not to like here? Why? Oh yeah, it has groups. What the hell? So it has groups. We need the array indexer, or we need the indexer syntax. Okay, so this parses the tile IDs. Let's see if this works a bit as expected. 3079, is that correct? Yes. Okay, so we're parsing tile IDs, and now let's parse the bitmap or the contents into a 2-dimensional array. How do we do that? What's the constructor part for array2ds? Yeah, this maybe? Oh, you just take a 2-dimensional sequence. You give it a 2-dimensional sequence. Okay, that's interesting. That's actually pretty easy, right? So for lines 1 and on, so let's do a computation expression. For line in every line starting from 1, and for so that's actually, is this enough? I think this is enough, maybe. So just line 0, 1, plop that into a 2D array, and that's the contents, I think. So let's extract that as well into a variable, and let's return the tile type. So we have something nice to work with in the rest of our code. There we go. Yes, no, yeah, maybe. It's working out better already than I expected, so that's cool. We maybe should verify whether we are parsing correctly the row and the columns. Check, 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 and then a sequence, and then a dot. Yeah, it looks like we are done with parsing at least. Cool. That wasn't too bad. What's the next thing we need? For part 1, we don't need to lay the entire puzzle. We need the 4 corner pieces. How do we detect corner pieces? Those are the only pieces that have 2 adjacent edges that don't match, or no. Yeah, actually, I'm making a lot of assumptions here. So, are there like duplicate edges? Like in a real life puzzle, you have multiple pieces with the same like edge. Do we have that here? Maybe that's something we should verify before we make it a working assumption for our code. Otherwise, we'll need to backtrack or test multiple configurations that could match. Yeah, otherwise. Okay, but in order to verify that assumption, we need to be able to rotate pieces and even flip them, right? Yeah. Flipping them doesn't sound too bad. Rotating them, I think it'll work out nicely with our data structure. Yeah, let's write rotate and flip. Flip horizontal, flip vertical, or both. Maybe we can do a combination of rotating and flipping to get to the same thing. I don't know. But let's focus on rotation first. So we need to be able to rotate a tile, or rotate the contents at least. Let's do rotate 90 degrees first. Or let's play around first, because I'm not sure what we're doing here. So let's make a matrix using our data structure. 1, 2, 3, 4. So a 2x2 matrix. How do we rotate this? So for example, 2, 4, 1, 3, or 3, 1, 4, 2. How do we do this? With slicing magic, I'm guessing. So actually, we need the columns, right? Yeah, we need every column. So that's saying, okay, for every row, just take everything and then take the... For example, take the first column. This takes everything in the first column, right? 2, 4. Yeah, so this is the... 2, 4 is actually the first row if we rotate counterclockwise 90. So let's do counterclockwise 90 first. So this takes the first row. What takes the second row? Is it... It's going back, so it should be this one, 0. Yeah, 1, 3, right? Yeah, that's correct. So this changes from 1 to 0, so it's counting down. Okay. So let's do a for expression again. 4, or can we do it in line? Can we do like a countdown here? I think we can. For example, array 2D. Let's get the dimension of the matrix. Are those things squares? I seem to remember they are square. Square, square, square. I'm looking for the word square. Yeah, they could produce smaller square image tiles, so it doesn't matter which dimension we take. -1. So this is the maximum index, and if we count down from the maximum index to 0, I think we just implemented the rotation. Need some parentheses because -1 is hard to interpret otherwise. Yes, no? What's the problem? I am pretty sure you can count down. What am I doing wrong? So for example, 1, 2, 3. I thought you could do from 2 to 0 by counting down 1. Huh? Is this not the correct syntax? Interesting. I thought you could do a... I'm sure. F# index count down. I don't know the correct term. For comprehensions, yeah, sure. That's counting up, counting with increments. So a positive increment works. And here's the example, but it's in a 4 comprehension. Let's try that. Maybe that's the problem. So 4 okay, 4 x in 10, counting down. Yeah, and let's yield that number. So this works. This works. This counts down from 10 to 0. Yeah. So why can't I use this over here? Is it the array length thing? Do I need parentheses here? Oh, come on. I know this is possible. Am I trying to do too much? Am I trying to do too much in a single line? I think so. If it's this tricky to figure out how to write it, I can only imagine it will be a nightmare to try to read it afterwards. Yeah, let's try to generate a sequence first. So it's actually 4x in array. Yeah. Do I need an array or sequence thing here? No, this is using slicing as is. Come. This works. Can I decrement? This also works. No. This starts to fail. Interesting. Can you not do a downward slice in the matrix? Interesting. Okay, so let's not do the slicing here. Let's do the slicing in a 4 expression higher up, sure. So for column in array to the length -1 down to 0. So these are the columns, and then just grab me the matrix part. So for the whole row thing, but for the column like this. Does this work? 2, 4, 1, 3. I think this works. It's a bit of a shame I have to drop a 4 comprehension around this. So if I take this, I cannot inline this here. Oh, apparently I can. No, then it starts to not like the... Okay, never mind then. This is rotation 90. I'll live with it being a bit hard to understand. But I'll make up with it. I'll make up for it by writing some tests. Let's wrap that in a function. Rotate 90. So if we rotate 90, this thing we should get 2, 4, 1, 3. Oh, come on. 2, 4, 1, 3. Yeah. So this is correct. What's not to like? Come again? I don't understand why it's not working. Oh yeah, that's why I didn't want to do the for comprehension. Now we're back in list world and not an array2d world. So I don't know if this is a performance hit, but probably it is. Let's see how it works out. For part 1 at least. Okay, this works. Okay, let's do one more. If we rotate 4 times, we should... Or can we do the rotation twice? Yeah, let's do the rotation twice. What are we expecting? Let's call our shot here. So let me draw something on my notepad. So it should be 4, 3, 2, 1. 4, 3, and 2, 1. So it should be 4, 3, and 2, 1. That's what we're guessing. If we rotate twice. 4, 3, and 2, 1. Yeah. Okay. Starting to look a bit weird, so let me just do the rotate after the matrix. That reads a bit better. Can we get rid of the... Yes, we can. So if we rotate once, this is the result. If we rotate twice, this is the result. Yes, and let's rotate the full 360 right now. So that's twice. If we do this again, we rotate 4 times. And that should be the initial matrix. So that's rotation down. Yep. Drop that in our tests. There we go. We can rotate. Can we flip? Flipping horizontally is just reversing the rows. Flipping vertically is reversing the columns, right? Yeah. So what does this look? Flipped horizontally, it's 3, 4, 1, 2. Yeah. So let's try flip horizontal. And there's probably a relation between flipping vertical and rotating, but I'm failing to come up with it, so never mind, let's write both of them. How do we flip a matrix horizontally? By just reversing the order of the rows. I think we can use the same trick we did here. Can I do a sequence dot reverse on a matrix? Probably not. No, we cannot. Can we do an interesting reversal with slicing? So flipping horizontally means keeping the row structure intact and counting down. Oh, this is exactly the same thing I want to do. Oh no, we need to keep the column structure intact, but we need to count down from a... So that's exactly the same as rotation, but instead of column, we need to do it with a row, right? So for every row, counting down to 0, keep the column structure intact, but grab the row. Let's try to flip our M horizontally. So what do we say? 3, 4, 1, 2. Yeah, that looks correct. Okay, let's encode that as well. Flip horizontal should be 3, 4, 1, 2. So our tests should all pass now, and we can flip and rotate. Yes, we can. Next step, flipping vertically. Flipping vertically. What's flipping vertically? It's the same thing. What does it look like? 1, 2, 3, 4. Should be 2, 1, 4, 3, right? Yeah, I think so. Flip vertical. So Flipping vertical means same columns, but in reverse order. So let's just build on what we have. Same columns, but in reverse order. So let's go over the columns again. Wait a second, this is exactly rotating. Where's our thinking error? Where's the thinking error? If we rotate 90, what do we get? 2, 4, 1, 3. And we should want to do... let me draw it out again on my notebook. I don't use matrices and rotations that often, so for me it's a bit of a draw it and figure it out kind of thing. Okay, and if we flip vertical, we have 2, 1, 4, 3. 2, 4, 1, 3. Are you kidding me? 2, 1, 4, 3. Yeah, so it's not the same as, okay, I was getting confused. So we need 2, 1, 4, 3, which is actually just reversing every row. Keep the rows order as they are, but reverse every row. Okay, so keep the rows as they are, but reverse every row. So count down on rows. So count up on rows and down on columns. It's something like this, but we've been doing that. Yeah, we've been doing the countdown on the other one. What am I missing here? What am I missing here? 2, 1, 4, 3. This is getting close. Come on, you have to be able to do a vertical flip with all the magical indexing we have. Or the slicing operators we've been using. Okay, so M is this. And we would like to end up with 2, 1, 4, 3. Which is literally looping over every row. So loop over every row, I think you can do it by doing this. Oh, come on, there is a syntax for this. What's the syntax? Oh, this is, let's give a single row. This is slicing a single row, yep. And just reversing that. But can we get all the rows in one statement? So that would mean moving up row as well. Oh, is this actually what we need? Iterate over every row, every column, and take every column, 1, 2, 3, 4. Yeah, but we don't need to slice, we need to reverse. So we need to iterate over rows. Yeah, okay. Okay. So, again, let's do the 4 thing. Let's iterate over every row. Let's grab rows. They don't have to go downwards. If that's the case, we can just type it here. So this is actually iterating over row. Okay, let's grab it into a computation expression. I'm getting confused. Let's do what we know works, which is this. And instead of looping from 0, or we have to count up, I mean. So this can all go. Now we're looping over every row. And we should reverse that, right? So this is 4, 3, 2, 1. No. Oh, come on. Oh yeah, sorry. I'm missing some slicing magic. There we go. What is this? Why am I... Why am I seeing 3, 4 twice? Eh? What did I do differently here? Nothing. So for every row, get me. Oh yeah, it's doing this for every row. So it's doing this and then this. That's not correct. So this is correct. Do we not need the dots here? Probably I'm not using the full potential of slices here. I think I'm not doing the I'm not using the full power. Okay, but this is the correct thing, but we need to reverse every row individually. Yikes. Thought we might have it's an array. I thought we might have a clean API with array 2D, but I'm not an expert enough. I think you can write almost all these things with just slicing syntax. But I'm not figuring it out right straight away, so forget it. I'll figure it out in my spare time when there's no camera on my face. So this is flipping vertical, I think. Oh, instead of throwing it away, maybe just put it in our buffer. There we go. Okay, I think we have our basic operations fleshed out. Let's try flipping vertical. And what was it supposed to be? 2, 1, 4, 3. So maybe take everything in. I think we have our parsing down. I think we have our basic operations down. Now we just need to do the easy part, which is solving the actual puzzle. Before we do that, let me grab the actual input to make sure that we can parse the real input as well, and to get a sense of the scope, because I think we have a lot of... Are the tiles numbered randomly? Yes, they don't increment. How many tiles are we working with? So $144, so that's a 12 by 12 puzzle. This is going to cost some CPU cycles. Okay, for part 1 we need to find the 4 corners, and we were trying to see if we could make assumptions that like every matching border is unique. But now that I think of it, we have a 12 by 12 grid. How many borders does that have? 2 by 2 grid has 1, 2, 3, 4. We have to find a 3 by 3 grid has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 borders. I'm trying to see if there's a pattern here. There is a pattern here, but I'm not seeing it. Should I start drawing on a... Maybe I should start drawing somewhere visually. Let's see. So I'm trying to figure out if we can do some shortcuts for part 1. Not lay the entire puzzle, but just figure out the corners. And I think I was trying to figure out if... Let's see if I can grab a pencil here. Oh, come on, my drawing app has crashed. Apple, why you do this? Is it because the pencil is dead? Yeah, it's because the pencil is dead. Cool. It's like a very expensive drawing tool, and pen and paper beats this very expensive drawing tool. So never mind, I'm not gonna draw using the tablet. I'm gonna draw here. 2 by 2 matrix. These are the borders, so it's 4 borders, 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. What's the pattern here? What's the pattern here? Okay, let's suppose that we also do the edges, because we can count the edges way easier. So then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 on a 2 by 2. And the borders are 1, 2, 3, 4, 5, 6. Yeah, so it's the circumference, so it's 8, so it's 4. How do we figure out 12? How do we figure out 12 from a 2 by 2? Every square has 4 borders, but they are shared by sometimes even 4. Are we wasting time? I don't know. We could just try it without validating our assumption, but that's tricky, because our example is several times larger than the example, so it might be that this property holds for the example but not for our input. That would be a real shame. Yeah, so let's noodle on this for a bit longer. How many borders does a puzzle of dimension n have? That's the formula we're trying to figure out here, and then we can use that to validate some assumptions. So how many borders does the total grid of 3 by 3 have? So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 borders. So it's what, 24 minus 12 equals 12? Is this what we're doing here? One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Yes. So we have n is equals 2, n equals 3. How do we get from this to that? The circumference part, that's easy. That's just dimension times 4. So how do we figure out this total number of borders? So let's write the formula down already. So 4 times n equals a number. How do we figure out this 24 or this 12? 12, 24. Is that a coincidence that it's like a linear scaling thing? If we would do a 4 by 4, what would it look like? We add more. Can I say 36? I don't know. Let's try it. So 12. Let's say no. This is a dangerous assumption. So let's try it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 extra. 24 plus 16 is 40. Plus 16 is plus 4 squared. plus 3 squared is plus 9. 12 plus 9 is not 24. I'm doing something wrong here. You know what? Screw it. We'll figure this out when we need to. I'm just gonna live like an optimist and assume that every border only matches at most once. Is that a mathematical possibility if you have 144 tiles? So if you have a 12 by 12 grid? Don't know. Could we figure it out? Yes. Do I want to figure it out? No. I've seen enough maths. I just want to noodle around a bit and see how far we get. So what I'm going to do now for part 1 is for every tile, figure out how many borders we can match with all the other tiles out there. And hope for the best that we only have like 4 tiles in there that only match exactly 2 borders. Yes, this is our part 1 strategy. Let's do a quick Hail Mary. Okay, I'm not religious, by the way. I just really don't want to dive into the mathematics today. I've done enough thinking for a year with a puzzle 18 and 19 with the parsing. So we have 144, but let's work on the example and let's try our naive approach by just looping over all the tiles we have and finding hopefully only 4 that match 2 borders. And let's hope that every border is unique and that we don't need to do any searching or backtracking. And otherwise, it will not be a short stream today. So, tiles. Find me the tiles, so it's a filter where so unmatched borders, yeah. Find me tiles where the number of unmatched borders for this tile in the set of tiles without this one where that equals exactly 2. So tiles. Come on. And okay, uppercase borders, so there we go. I think if our assumptions hold about the borders being unique, then this will work. So let's calculate the number of unmatched borders, or the number of matched. Is the same. So how do we find the number of matched or unmatched borders for a tile? We need to look at each of the 4 borders, but it can be flipped. Oh dear. No, let's keep the tile for reference. Let's keep that unflipped. And let's start rotating and flipping everything else. Does that make sense? If I were laying a real-life puzzle, what would I do to find all the borders? Do the borders have a unique look, like in a real puzzle? No, there's just random. It's not like they all have like a pattern. My coffee is ice cold by now. Ugh. So given a tile and a set of all the other tiles, how do we find? Let's assume the unique border property. So actually for every border of our current tile, we would like to find the tile, if there is one, that matches. And matches meaning we can rotate that tile and we can flip that tile. So we see every configuration. What is every configuration? Flip it horizontally, flip it vertically, and rotate it in the 3 configurations? Have we... I mean, if there's a combination of rotation and flipping, do you always get to the same configuration by just applying one operator? That's something I would have to think about. But let's try the naive strategy. Okay. So for every border in the tile, and maybe here's where our 2D array 2D thing works out. I think we can grab borders easily. Yeah, let's write a function borders of a tile, and it returns a sequence of characters. And we don't need to have all configurations. No, let's just keep the tile oriented as it is, and let's grab every border from it. So that's a 2D, or let's just type this. This is a tile, so we keep the tile ID during our calculations. How do we grab the left border? Let's grab an example again. Our 1, 2, 3, 4 matrix will do just fine. So bye-bye whatever I was trying here. Hello 2D matrix. 1, 2, 3. Oh, my writing. So the borders are 1, 2, which is the first row, 3, 4, which is the last row, 1, 3, which is the first column, 2, 4, which is the last column. It sounds like something that should be really easy to grab. So tile contents, first row is 0, and take the entire column. Sure. What's contents again? A char. I'm thinking of doing the actual extracting the actual tile contents a bit like this, so then we can play around with it more easily. It's a context independent now. This works with any kind of matrix, not just the tile structure. Okay, so do we still have M? Yeah, we do. Is it still here? Yeah, it's still here. Okay, so we can play around with it a bit. So I think that borders of M should now return the top row. Yeah, let's grab the bottom row as well. Whoa, 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 whoa. My home button on my other keyboard is my Windows button here. It's, or my control button. Yeah, I'm totally sidetracked by keyboard layouts. Okay, so this is the top border. Let's grab the bottom border, which is array 2D, length, whatever, of our tile, -1. So this grabs the bottom row, right? 1, 2, 3, 4, yeah. Now let's grab the left-hand column. This is where those array 2D slicing tricks really, here I understand them. This I can do. So, so the left column is take for every row, but just take the first column. So I think this should return 2, 4. No, it's returning 1, 3. Oh yeah, 1, 3 is correct. I was looking at one of my rotated matrices. Yep, so this is correct. And then take the right border, which is chalk, chalk. What should I change now? I should grab this and plug it in. Where? Instead of the 0? What am I expecting? 2, 4 to be in the result set. 1, 2, 3, 4, 1, 3, 2, 4. This looks correct. Yeah, let's encode that in a test. So borders, I for a matrix, what do you get? Exactly what we had here, yep. It's not a matrix, it's a list. Let's convert it back again. Yeah. I'm really curious about the performance of converting lists to array2ds. Is this just like an adapter over it and does it not copy data, or is it a painful operation? Don't know. But now we have a 2D matrix, yes. It's really... Actually, this was nicer to copy paste in my test. So there we go. Works? No, doesn't work. Or does it work? Yeah, it works. Okay, now we can find the borders of a tile. Now we would like to find the matches, or in our assumption, the single match, hopefully, for every of those borders. So borders of the tile. And now let's find if we have matching borders for every configuration of every other tile. Oh, this sounds like an expensive thing to do. So let's generate every configuration of every tile. Oh boy. So let's write a function configurations that generates every possible rotation, flippage, whatever of a tile. Borders of tile.contents, that would be more fun to work with. And let's keep the return type to keep the compiler happy. There we go. So configurations of a tile. Let's think about this. Let's draw a 3x3. Let's draw a 3x3. What are all the possible configurations for a 3x3 matrix? Should I do 3x3? Maybe we can pass a 3, 4. Whoa. So we can do the 3 rotations, which is what are we doing counterclockwise? So it's 2, 4, 1, 3, and it's 4, 3, and 2, 1, and it's 3, 1, and 4, 2. And when we rotate again, we're back at the original. Yes, that's correct. Can we flip? We can flip. That's a configuration we haven't seen. So 3, 4, 1, 2. And can we flip vertically? 2, 1, 4, 3. If we do something like flipping this one, we get something we already saw? Yes. If we do something like rotating this, do we get something we already saw? So if we rotate this, we get 1, 3, 2, 4. Oh no, it's not in there. So these are not all the permutations for this puzzle piece, right? Do we need to be able to do it that way? Is it like rotated or flipped, or rotated and flipped and rotated and flipped? By rotating, flipping, and rearranging them. Yeah, there's no constraints on the number of operations we can do. So yes, if we have this and we flip it, we have 4, 2, 3, 1. That's nowhere in our lists. So for every rotation we need to flip, or for every flip we need to rotate. Am I correct? Is 1, 3, 2, 4 in there? No, no. Yeah, I think we need to do both. And if we then do it again, I think we've exhausted We have 1, 2, 3, 4 numbers. So is this basically saying how many permutations can we have? That's 4 factorial, probably 4 times 3 times 2 times 1 equals 12, 24. Yikes, we're nowhere near 24, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. We're missing some. We're missing some, right? So these are rotations. These are flips. If we flip a rotation, we get stuff we haven't seen. And there's only 2 flips. So let's do that. Yikes, maybe not this big a jump. So flip is 1, 3, 2, 4, and 4, 2, 3, 1. Are those new configurations? Yes, they are. Okay. And we do the same for this. So it's flipping it vertically or flipping it horizontally 2, 1, 4, 3. And flipping it vertically 3, 4, 1, 2. And the same for the last one. Flip it horizontally 4, 2, 3, 1. And 1, 3, 2, 4. Okay, so now we flipped. Yeah, so this is the horizontal flip of the original. If we rotate this, do we find something new? No, that's the same as this. Rotating and flipping and rotating ends up in the same. Does it end up in the same? So for tile, calculate like all rotations and then just do the flip horizontal and the flip vertical. So that's 1, 2, 3, 4 times 3 equals 12. And I was thinking more in the range of 24, but I think it's correct. So generate the rotations and then flip every. Okay, so we have a tile. We have a tile and we have the rotated 90-degree tile and we have the rotated, let's do it this way, just as in the tests. So we have a tile, we have a rotated 90-degree tile, we have a rotated 180-degree tile, and we have a rotated, I think it's faster if we implement rotate 270 instead of doing 3 times rotate 90, but that's okay. And then for these 1, 2, 3, wait, there's only 3. 1, 2, 3, 4. No, it's 4. So for these 4 rotations, we need to flip everything. So that's this, and then flip everything. So it's a sequence dot collect. So the tile and the flipped tile and the flipped vertical tile. So this is the list of all tiles. And just for good measure, let's do a distinct, because we might hit some duplicate calculations. But if that's the case, then we're doing too much work and we'll burn our CPU even farther. So let's try it out with our M. Without the distinct, because that's what we just saw. We are expecting 4 times 3 is 12 configurations. 8. What? It's even without the distinct. How can this be? What am I missing? Oh, there we go, 12 now. So yeah, it's 12, but apparently distinct is only returning 8, so there's some duplicate work here. Where's the duplicate work happening? Are we gonna worry about it? Maybe not, but this is definitely a performance problem if we have to do this a whole lot of times. So if we're burning CPU, this might be something to clean up. Okay, so now we can generate configurations. So we can throw away the tile ID here. There we go. So, no, is this not a problem? Read the error before you try to fix the error. It's a bad habit of mine. What is this saying? So it's a list of matrices. And configuration takes a single tile, or the contents of a single tile. So I think this was correct what I was trying to do. So this should be tile.contents. What's it? Oh, now it's working. No, it's not. Result of this expression is a... Let's get rid of the -1. No, it's not a problem. This expression was expected to have type a list. There's type sequence. Ew. Oh yeah. Mixing up sequences and list again. So let's keep everything in the list world. There we go. So now we can generate all configurations for a given tile and do it like a bit too eager because there's some duplicates in there. But anyway, so these are all the configs, all the configurations. And now we can just grab the borders of each of those and see whether that matches the borders. So yeah, let boards per config is, this is a heavy calculation. Should we do this lazily? We probably should. Let's not worry about it right now. So let's map every tile to its borders. So now we have like a list of borders, which represents the tiles. And now we can, for every border, find the candidates that match. Yeah, maybe we shouldn't do this here, but like nested here, that'll make more sense. So, number unmatched borders. So let's filter. Let's first map them. So a border for our current tile. Let's find how many tiles match. So configs, and then actually this. So let's do that anyway. So these are like all the borders for every other tile. And let's look up how many of those tiles have a border that matches. So let's keep them all. So let's do a filter. Border config, so borders per configuration. So it's a configuration border. It's a really crappy abbreviation, but okay. So this is a list of borders for configuration. And then we say there contains our current border. So now we have, what do we have actually? Nothing. What's not working? Okay, was just no, it's not working. A car matrix is not work. Well, what's still a car matrix here? Oh yeah, these are 2D arrays. So list filter won't work that much. Yeah, this works. This works. Is this list contains thing? Yeah, list contains is not okay. Because this is a car 2D array. Now it would have been nicer to work with a flat list instead of a 2D array. How do we do that? What is the return of configurations? The return value? We have a test for that, right? No, we don't have a test for that. I think if you write a test for that, we'll figure it out. So let's do that. Configurations for a given tile. So let's try to find configurations of our favorite matrix. Ooh boy. Which contains 8. Why am I looking at configurations? I should be looking at borders, right? Sorry. So let's forget about this part. What do the borders look like again? Why am I returning an array 2D when I'm working with borders? That's weird. So let's look at borders again. Why am I mapping this into an array 2D? No need. No need at all. So yeah, a list of borders. That'll be more fun to work with. Int list. Yeah, that works better. Way better. So now I think this will be more a sequence of a car list. There we go. Whew. So what is the type of foo? A sequence of a list of characters. No, a list of an array of characters. Nope. Borders. Borders is what we just saw. So borders is, what's the type of borders? A list of numbers. Does that make sense? Yes, that makes sense. So this is the first border, there's the second border, the third border, the fourth border. That is correct. So borders looks correct, or to be what I expected to do. Configs gives me a list of 2D matrices, yes. Borders per config, this is where it gets confusing. Maps the borders to every config. And then we say for every border, keep the, actually you can do a count by. There we go. This will be probably better. A sequence of a sequence. A sequence of a sequence of bools and ints. Bools? Where's this bool coming from? Yeah, that's not what I want to do. There we go. Yes, now we're filtering. So for every border, for every other configuration out there, we have a border or the list of the borders for that specific configuration. Do we have a, does it contain a border? So I think we're almost there. I'm only confused as to what this actually means. A sequence of a list of arrays of characters. No. No. Should we extract some functions and type it to see what's going wrong, or where I'm losing my train of thought? Maybe. Maybe. Or instead of keeping this configuration, let's just count it, or count a number. So this makes more sense. Borders are 4 borders, and then we say, okay, map every border to how many configurations have a corresponding border. So yeah, how can, no, oh, it's not map, it's a, yeah. Okay, so these are the numbers. So now we should have, so this is saying like, okay, this border matches 0, 1, 2, 2, and so the unmatched ones are the ones where we have a 0. So let's, so these are the matches per number, matches per border. That's what this statement is saying. And we're saying, let's just count the zeros. This can by keeps tripping me up. It's a, I know you can combine a filter with a length. But I don't no, I've been hammering at this problem for too long to think clearly. So I hope this actually works. Our assumption holds. So find me the ones where you have 2. How many do we have? Please say 4. This is for the example, right? Let's hope our input also has this. We have this much luck with the input. Where do we define our tiles? Let's grab this out. Ooh, I'm actually a bit excited because I hope it works, and then I can take a break and enjoy life. So we have our 144, yes. How many corners? Computer is taking liftoff. 4, oh my god. I think part 1 is solved. So we took some dangerous assumptions and my brain was too fried to validate them, but it looks like it's a safe bet. And we need to multiply the tile IDs. So corners. Let's just grab the tile IDs out of there. What's it called? Oh crap! I'm throwing away the I'm throwing away the tiles. So let's throw everything away. So no, yes. Oh, I shouldn't have done the sec length. So we can run our entire thing again without doing a length. And now for every corner, let's grab the tile ID and let's multiply. Oh, I did sequence instead of list, so it was lazy, so it's only doing it now. No, it's a long instead of an int. That's not a problem. So let's do a fold, and let's provide a multiplication. So the 0 element is this. Let's do a long. Oh yeah, we could have done the same with the reduce, but just parsing our ints to a long. There we go. I should have done the to list. Oh well, if it takes this long for part 1, I am wondering what part 2 will be like. But I'm not even gonna read it. I'm just gonna enjoy life. Yeah. Thank you, Eric. Thank you for not making it too hard, or at least not part 1 too hard. So I will be calling it a day. No, not a day, but I'll be taking a break because this has has been pretty tiring already, and I see a lot of part 2 stuff. Yeah, I'm gonna go for a quick break. Really fun puzzle. We're doing too much work. We know this to be a fact, but I like the puzzle. So I'll see you a bit later today for part 2.